We physicists have waited 100 years since 1916 for this photograph.
Black holes, mysterious cosmic phenomena capable of devouring entire stars, distorting space and time and trapping light, have been a subject of fascination and baffle for decades. But what if I told you that recent advancements in technology have allowed us to uncover something unprecedented? With the James Webb Space Telescope, JWST, now in operation, scientists are exploring these enigmatic entities like never before, uncovering secrets that could fundamentally change our understanding of the universe. Voyager is embarking on an exciting expedition to explore the mysterious realms inside black holes, using the latest data from the James Webb Space Telescope, JWST. This journey challenges our understanding of black holes, the birth of galaxies, and the universe's ultimate fate. Before we delve into the new discoveries, let's revisit what we know about black holes. A black hole is formed when a massive star exhausts its nuclear fuel and collapses under its own gravity. This collapse is so intense that it creates a singularity, a point of infinite density where the laws of physics as we know them break down. Surrounding the singularity is the event horizon, a boundary beyond which nothing, not even light, can escape the black hole's gravitational pull. However, black holes are dynamic, complex objects rather than merely empty spaces. Space-time is warped by their strong gravitational attraction, drawing everything in their vicinity into a funnel-like structure. Anything that passes the event horizon is irreversibly lost to the black hole and is caught in an unbreakable spiral that leads to the singularity. These mysterious objects range in size from stellar black holes, which have a mass a few times that of the Sun, to supermassive black holes, which have a mass millions or even billions of times that of the Sun. Black holes were thought to exist only in theory for many years, having never been directly observed, despite being predicted by Einstein's general theory of relativity. The discovery of Cygnus X1, a powerful X-ray source in the constellation Cygnus, in 1964, provided the first indication of their existence. The discovery that this object was, in fact, a black hole signaled the start of our quest to comprehend these enormous cosmic creatures. Numerous black holes have been found over time, and each one has revealed something new about the enigmatic nature of these objects. The James Webb Space Telescope, launched in December 2021, is the successor to the Hubble Space Telescope and boasts advanced infrared sensors that can peer through cosmic dust and gas, uncovering the hidden secrets of the universe. Its infrared capabilities are crucial for studying black holes, as they can penetrate obstacles like dust and gas, allowing scientists to see previously hidden objects. James Webb Space Telescope. Most significant contribution is its ability to study black holes in the early universe, allowing us to see the universe at a fraction of its current age. This is crucial for understanding how black holes and galaxies evolved over cosmic time. James Webb Space Telescope is also equipped with a coronagraph, a device that blocks out starlight, allowing us to study faint objects around it, revealing new information about their size, structure, and behavior. One of the most amazing discoveries from JWST is the identification of Gaia BH3, a large dormant black hole in our galactic neighborhood. Gaia BH3, the largest stellar black hole ever found in the Milky Way, has 33 times the mass of our Sun and is situated in the constellation Aquila, barely 1,126 light-years distant. The surprising thing is that Gaia BH3 had not been discovered until recently, considering its size and closeness. Gaia BH3, a massive black hole, was discovered by the European Space Agency's Gaia mission, which was designed to map the positions and motions of stars in our galaxy. The discovery has profound implications for our understanding of stellar evolution and black hole formation. Most stellar black holes are formed from stars around 10 times the mass of the Sun, but Gaia BH3 is unique. It raises questions about the life cycles of stars and the processes leading to the formation of massive black holes. One hypothesis suggests that stars with lower concentrations of heavy metals lose less mass over their lifetimes, allowing them to form larger black holes. Gaia BH3's companion star, also low in metals, supports this theory, suggesting that metal-poor stars may be the progenitors of the universe's most massive black holes. Although Gaia BH3 is an exciting discovery, James Webb Space Telescope has discovered other black holes as well. A supermassive black hole with an intense red color that is roughly 12.9 billion light-years away from Earth is another amazing finding. One of the oldest and furthest black holes yet found. This one has a mass of almost 40 million times that of the Sun. It is located in a galaxy that is far smaller and less evolved than our own, but it is home to a massive black hole. This supermassive black hole is especially fascinating because of its reddish color, which is brought on by the dense layer of gas and dust that surrounds it. This implies that the black hole is still expanding and rapidly consuming its surroundings. Significant concerns concerning the interactions between black holes and their host galaxies are brought up by the finding of such a large black hole in a comparatively tiny galaxy. The reddish hue of this supermassive black hole, caused by the thick layer of gas and dust surrounding it, makes it particularly interesting. This suggests that the black hole is continuing growing and engulfing its surroundings quickly. The discovery of such a massive black hole in a very small galaxy raises important questions about the interplay between black holes and their host galaxies. One of the biggest mysteries in astronomy is the question of which came first, the galaxy or the black hole. The discovery of this red, supermassive black hole suggests that black holes and galaxies may grow together, influencing each other's development in ways that we are only beginning to understand. This discovery also has implications for our understanding of the early universe. By studying black holes like this one, scientists can gain insights into the conditions that existed in the universe when it was just a few 100 million years old. James Webb Space Telescope uses gravitational lensing, a technique where a massive object bends the light behind it, allowing us to see distant objects that would otherwise be invisible. This was crucial in the discovery of the red supermassive black hole, as the light from this distant object was magnified by a galaxy cluster, making it visible to James Webb Space Telescope as a series of red spots. Gravitational lensing has become an invaluable tool for astronomers, allowing them to study the most distant and faint objects in the universe. It also allows scientists to probe the distribution of dark matter, which makes up about 85% of the universe's matter. By studying the way light is bent by gravitational lenses, astronomers can map out the distribution of dark matter in galaxies and galaxy clusters, helping us understand the role dark matter plays in the formation and evolution of black holes. If you've enjoyed this deep dive into the mysteries of black holes, don't forget to hit the like button and subscribe. Thanks for watching, and until next time, keep looking up.